Hello guys, welcome back to lecture series on discrete mathematics. Here we back with the second point from the unit sets and proposition. So we are going to learn some of the important sets here in our today's lecture. We are taking some important set that will be the helpful for our subsequent lecture series. Okay, so here we have first set which is a universal set. Okay, that you all already familiar with this. Okay, that we are taking for our next examples and Venn diagram. Okay, first we have universal set. Okay, universal set. So that universal set we need it. Okay, mostly we denote universal set by capital U. Okay, like a capital U can be denoted as a universal set. Okay, yes, actually what is meant by universal set? A non-empty set of which all the elements of a sets under consideration are subsets. Okay, the element under that set, when whatever we are taking as under consideration, that should be the subset. Okay, so that when we call the universal set. Okay, a non-empty set, let me write that set should be the non-empty. Okay, a non-empty set. Okay, a non-empty set. What property which we have for the non-empty set? Of which all the sets, of which all the sets. Okay, the non-empty sets of which all the sets under consideration are subset. Under consideration are the subset. Okay, that one called as the universal set. Okay, yes, like in our previous Venn diagram we have learned complex number, set of a complex number is the universal set. Okay, under this subset we can real number, rational, irrational, integer, all are the subset of it. Okay, so set of complex number there we consider as the universal set. Okay, so I'm not taking this one. Okay, example, I hope you all have understood the concept here. Okay, yes, now next we go for the singleton set. Okay, second we have singleton set. Okay, singleton set, that means the set which have only one single element. Okay, singleton set means single element present only. Okay, single element. Okay, only single element is present. Okay, then we call it as a singleton set. For example, if I consider set A, this has only single element as a 5. Okay, now you can take one more example, B as a 5. 5 means there exists only a single element in our set B. Okay, that we consider as a 5. Okay, yes, this one is a singleton set. Okay, now third type of the set, finite set. Finite set. Okay, what actually the meaning of a finite set? Okay, the set which has a finite number of element present. Okay, the set which has finite number of element present. Okay, the set which has finite number of element present, we call it as a finite set. Okay, for example, if I consider set A as a 1 2 3 A B. Okay, number of element in A, in set A. Okay, what is the number of element in A? Total number of 5 elements. Okay, that means set, we call it as a finite set. Okay, so this is the actual meaning of a finite set. Why we are learning finite? Because we need to know what is actually the meaning of infinite set. Okay, now fourth point, the fourth type we are taking infinite set. Okay, that one is important here. Okay, infinite set. Okay, the set which has infinite number of element. Okay, infinite number of, the set which has infinite number of element, call it as the infinite set. Okay, so if I consider set n, okay, capital N as a natural number. Okay, set of natural number. Okay, so number of element in a set A, which is the infinity. Okay, so we know that the numbers start from 1 2 3, but we don't know where it is ending. It has infinitely many elements present in a natural number. Okay, so that's why we call it as the infinite set. Natural number is not only the infinite set, entire complex number is infinite set, entire real number is infinite set. After that, a real number, natural number, complex, integer, all number sets are infinite set. Okay, yes. So we go for the next point. I hope you all have understood universal set, finite set, infinite set. If you want this point, you can note it down for your understanding. Okay, so we continue it to the next point. Okay, so next point we have cardinality of set. Okay, cardinality of set. The simple meaning, actually this is like a little advanced word that it feels like a little difficult, but in actual it is like nothing. Okay, cardinality of a set means number of element which present in that set. Okay, so I'm writing in small and we designated or denote this one as a like this mod. Okay, cardinality of set. Okay, so that is number of element present in a set. Okay, number of element present in a set called it as the cardinality of a set. Okay, so for example, if I consider natural number, okay, number of element present in a set, so cardinality of a natural number is infinity. Okay, that means number of element which are the present in our given set. Okay, so if you take another example as a capital A set as a 1 2 3, cardinality of A is a 3. Okay, so this one is the example for the cardinality of a set. I hope you all have understood the meaning of cardinality of a set. We go for the next important point, power set. Okay, so guys, you all are the familiar with all these points, that's why I'm taking just little faster. Okay, so you are already familiar of this one, that's why. Okay, power set, that is what is meant by power set. Set of all subset of a given set. Okay, set of all subset of given set. Okay, set of all subset of a given set called as the power set. Okay, it is like simple meaning, guys. Okay, all element which present in our given set. Okay, that means element, their subset, all these things are present where we call it as a power set. Okay, yes, for example, let me explain with the example. So I'll take the 2 element and then we go for the 3 elements. Okay, yes, example first. If I consider set A as 1 and A, these 2 element I consider. Okay, so cardinality of set A is a 2. What is the power set of A? Power set of A we denoted as a P of A. Okay, power set of A we denoted as the P of A here. Okay, yes, so power set of A we write, now see that every, okay, in our set phi is a subset of every set. Okay, that means phi is the element which present in every set, but it cannot be visible, that we consider that one, that set is the subset of every set. Okay, so first we take phi, second we take singleton set 1, next we take singleton set A, then after that we take 1 and A. Okay, now see that all the set we have taken here, 1 2 3 4. Okay, these all are the subset of our given set. Okay, set of all subset, these are, see that 5 is a subset of this one, singleton 1 is subset of this set, singleton A is a subset of a set A, singleton now here twice 1A is a subset of a set A. Every set is a subset of itself. Okay, that means 1A is a subset of A also. Okay, now here you can see set of all subset is a power set of a given set. Okay, yes, so this one is for the two numbers. So if we take three numbers, for example, if I consider set B as A, B and C, I consider set ABC under curly braces. Okay, what are the power set of a B? Okay, power set of a B denoted as a P of B. Okay, power set of B, and the all subset, I want the set of all subset of that set. Okay, so here phi can be considered as its subset. Singleton A is also subset of a B, singleton B is a subset of B, singleton C is also subset of a B. Okay, so these all are the subset of given set. Okay, now we can see twice order. Okay, that means order pair like EB, AC, BC, EB, AC, BC, and last A, B, C. You can see that all these elements are a subset of a set B. Okay, that's why we call P of B as a power set of B. Okay, so what is the cardinality of A? Cardinality of A is a 2. Cardinality of power set of A is equal to 4. Cardinality of B, cardinality means number of element in our given set. Cardinality of a set B, which is the 3. And cardinality of a power set of B, which is equal to 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can see that there is some relation, cardinality of set A, cardinality of set power of set of A, cardinality of set B, cardinality of power set of B. Okay, so with this relation, I would like to add one of the remark here, which is very much important for finding the power set of a given element. Okay, okay, if set A has an element, if set A has n elements, this implies, okay, if set A has n element, this implies power set of A, P of A has 2 raised to n elements. Okay, 2 raised to n elements. Okay, if a set A has n elements, then power set of A has a 2 raised to n elements. You can take any example from upside here for understanding this remark. Okay, so consider set set B has 3 elements. Okay, set B has 3 elements. Okay, power set of B has 2 raised to 3 element, means 8. 2 raised to 3 means 8 element. Now see that you can observe here power set of B also have here 8 elements. Okay, yes, and that one is easy, guys. I hope you all have understood this remark. It is very easy to understand. Okay, a power set, which is important here. Maybe you will get the question based on this, like for finding the power set of a given set. Okay, so you supposed to understand how many elements are there. Okay, yes.